Good morning, it's Arturo Lobo, responsible of Arcrea Solar Project, which has been carried out by a small group of engineers and architects to develop a solar heating system with generation of changing aesthetics. This project has received a Research and Development Award and it has currently two worldwide patents pending. At the wall of video, we want to present the main patent in detail, and also the description about some products and several aspects related with the technology. Whose aim is illuminate with a sunlight house or a building or absorbing that energy, according to the thermal demand curve and without mobile elements. It means the system absorbs much more energy in winter than in summer, and that is necessary to be able to dimension a solar heating system, which in winter needs 8 times more energy than domestic hot water, that ACS curve, and nothing in summer. In addition, that technology allows generate pictures or colors on the building's facade without additional elements. Those images or colors could change with the sun or spectator position, as well as this system is able to generate high concentration. To understand the system, it is recommended to start by the videos of summary and basis or fundamentals. We apologize for the simplicity of these videos, which has been created by the research team itself, only with educational and informative intention. This introduction, with a length of 1.5 minutes, is repeated in all the videos. That video is more technical than the other ones. For that, it could be boring and hardest to understand for inexpert people. All the technology is backed up on a basic element that will be named as CIA, made by a little reflexive concentrator, an absorbing area, and the surrounding zones to that absorbing area. All those elements are fixed. The system is composed by arrays to extrude elements. That means adjacent rows of linear concentrators, and these elements, which could take up a whole wall. At the invention for that basic group, the CIA, the geometry, and all the design parameters are determined to optimize the function and aims. These aims are collecting or illuminating according to the thermal demand, creating imaging on changing colors, and generating high concentration. That optimization could be for any of them, individually or any combination of these aims. Also, the concentrator more appropriate is a parabola in which the vertex zone is perfected. Sometimes an ellipse gives better results, and many of these results are applicable to other forms of concentrators. During the largest part of the day in summer, the sun is high. When this happens, the concentrator reflects the incidental light into the sky. This contributes to reflect the building, the environment, and the planet. In spring, autumn, and partially in summer, the sun is not so high. In this case, the incidental light reaches the zone that is close to absorbing area, but the incidental light does not touch the absorbing area. Due to this, the system does not collect much energy at this time. When the solar heat is typical of winter, the concentrated radiation falls on the collecting area, that is touching the captation area most of the time. Therefore, this area collects a lot of energy over the course of the day. At first hour in the morning, the reflected radiation falls on the nearest zone to the absorbing area, that is located at the internal side, but the radiation doesn't touch directly the absorbing area. Because of this, it is badly collected. Although it could seem paradoxical, the sun in winter is during a long time at this low elevation. If this energy has harvested in winter, probably it will be collected also in summer, when it's more important to collect as little energy as possible. And also, because to collect that energy should be expand the absorbing area until these yellow or pink zones. That reduces the collecting efficiency because the area will be bigger and therefore it will have more heat loss. That is less certain if the absorbing area is a vacuum tube. They have a very low heat loss coefficient, and the vacuum tube could be placed at the black, yellow, or pink zone, if that is necessary. Anyway, the optimization of each locality of wall orientation determines how much absorbing area will be extended. for standardized values. The collection will fit to the seasonal demand curve. These four pictures also show the basic foundation of the generation of images and changing aesthetics. When the sun changes its position, the concentrated light falls on the different surrounding zones to the observing area. If these zones are colored as the image shows, the lead color stands out from the others. In this way, the facade is changing colors along the day. Just with this, the effect wouldn't be as spectacular as the simulation shows. But as the concentrators are elongated in other sections, the green zone could be painted in other color. Thereby, they could form a stripe of pixels along each linear concentrator. That's similar to the horizontal stripes of a screen, which form an image on the wall. At this case, when the sun changes, other band is illuminated and all the linear concentrators. Then the image on the facade changes, with intermediate transition as is shown at the screen. Actually, the optimized procedure is pretty more complex and it includes the determination of the form of these adjacent surfaces to the observing area. All of this is for generating the largest number of images as possible. In addition, it's created a variant and perfection using concentrator, which looks down, the opposite to the shown layout. If they are designed according to the patent, they could collect energy at the same time that images are changing. It is also indicated a procedure to minimize costs. All of this is explained in detail at the video number 5 about generation of changing images on the facade. To get high concentrators, it's identify the focus envelope and the geometrical optimizations for getting these concentrations were as high as possible. Especially relevant is the position of the point 1, which is also the beginning of the net concentrator. The focus envelope supposes an additional improvement to the generation of images. The geometric place where the maximum concentration is obtained is an undulating curve. This curve with an optimizing design could approximate to a straight line, which begins at the point 1 and finishes at the focus of the parabola. When the sun position changes, the zone where the sunbeams are concentrated in other place of that focus envelope and a pipe, which will move taking up this zone all the time, could be receiving a concentration around 30 or 40 when the elevation rank is approximately 30 degrees. Surprisingly, the results considerably improve if the panel is inclined to the ground instead to the sky, as is usual. These numbers compete with the system of tracking a shaft, with the advantage that the pipe could be insulated at the major part of this contour. Since the block of parabola could be very light and be located behind a glass, sometimes could be simple in styling the system fixed and move the block of parabola along to a guide. That guide will have the form of focus envelope. These concentrations are high enough to produce steam and move a little domestic turbine that generates electricity with efficiency higher than 30%. The performance is really greater than for the photovoltaic panels, with the additional advantage that steam or surplus energy will be used to heating, increasing the total efficiency. On a different topic, to get the fit on the demand curve, the geometry, the disposition of elements and parameters which take part at the problem have been optimized. For example, the maximum and minimum elevation that are expected to be collected. As stated, the concentrator is a parabola which has been improved in a zone next to the vertex. However, the ellipse could give better results for some reset problems. That near zone to the vertex is the stretch of the concentrator, which stays in a shadow when the solar elevation is the maximum, which is expected to collect. That is the stretch, from 15 to 2. This stretch is named surrounding vertex, and it is improved for make the observing area, from 18 to 19, as little as possible, or to that concentration get bigger over the focus envelope, giving as a result a circumference. The position of the point 1 is very important during all the optimization process. That position generates the shadow and the position of the next concentrator. The place where the absorbing area is located is determined after the indication of the shaft of the parabola was optimized, the length of that parabola, and the maximum and the minimum elevation when the energy is harvested. The previous points are the main parameters of the fitting to the thermal demand curve. They have been optimized for several cities around the world. In addition, it has made clever direct correlations with the geographical latitude and the wall orientation with respect to the south. Other positive effect about the fitting of the demand curve, which is claimed at the patent, is letting that the linear concentrators are not on the horizontal flat, but they are inclined. Geometry optimizations are modified when the solution for a roof instead the shown ones which are for vertical walls. They are also different if the concentrator is looking down, or according to the system designed to improve the collecting. They match generation or a solution about the combination of both of them. Other variant of the technology is to redirect the light and the energy toward the door of the housing or the building instead to collect it. It's done by a reflexive surrounding area. As happens with the concentrator, it could be a complex curve, but for optimized design could be an ellipse or a circumference. This could be seen in detail at video 4. When the aim is to collect energy, not redirect the light towards the interior, this is used to heat air or water. Traditionally, water is more usual and easier for the distribution, either as radiators, as a heating floor, or a domestic hot water. In that invention, it is taken into account a system, which is a heating wall. This will be installed pipes inside as a fabricated concrete wall, and using the external side of it as an absorbing part. This even could have the enclosure function and insulation of a wall, such as in that picture. However, the solution that heat air instead water sometimes are favorites for this invention by the simplicity and an economy at collecting energy. As is shown at video number 4, the external air which will be heated could be used to circulate by a heat pump if it doesn't reach enough temperature to be directly injected to the building. Some of this proposal represents new challenge for architects, using also the changing aesthetic given by that technology. They could get great innovation at edification and building systems, above all in prefabricated systems. The most obvious procedure to use the heated air is to transport it by ducts to the different rooms of the building, such as is shown at the image where the heated air in the panel of the left side as south is taken toward northern rooms that are not sunny. However, a greater challenge is to build a floor and wall system with air circuits, not water circuits. This is proposed is to build the ceiling with hollow core slabs and use their ducts to form a serial or parallel circuit. They will cause little pressure leaks due to the great pass section that they gather. The challenge is to get continuity of these circuits, as well as recirculating this heated air by the air chambers into the external walls, which had to be insulated. A bigger challenge will be doing that with a slab of hollow concrete blocks. In these two cases, the air circulates inside walls and slabs. This air heats them, but without being injected at the rooms. But could the system be hygienic enough so the air can be injected into the room? Or could the baking board, such a plastic board, be used to achieve a heating wall? Could hygienic circuits with baking boards be created and to inject the heated air into rooms? And in this case, the panels are on the left and down, which could be east and the south, for example. On the other hand, it's important to highlight that In that invention, the concentration is not mainly used to make bigger the collecting efficiency. It is used to control to get the limitation of the harvesting between the max. The video 9 and the next one show the prototypes and explain how to get benefit of the project. Those benefits could be gotten at individual level or for a company, as well as economic and social environmental benefits. If you want to produce or you are an interested client, we give you more details on free drawings. The project has social and supportive components. Watch the videos about how to work, to collaborate, to translate, and so on, and helps to spread them. Click to see the other videos or go into detail on this one.